Welcome back. Today's topic is numerical problems on mesh analysis. In the last lecture, we have seen how to apply mesh analysis technique for analyzing a given circuit. We have seen the steps involved in applying mesh analysis method, and we have done simple problems on solving a network using mesh analysis. So today's class we will try to determine the mesh currents, the branch currents and the branch voltages in a circuit based on mesh analysis. So I'll start again with the steps involved in a quick recap of steps involved in mesh analysis. We have seen that there are 6 steps. The first one is identifying the number of meshes in the given circuit. The next, we assign a current to each of these meshes, and then we will identify the current which is flowing through each of these elements, and then we will apply KVL for each of these meshes, and we will determine the mesh currents using the equations which we obtained from step number 4. And finally, we determine the branch element or currents. Right. This is the procedure which we have applied in our last lectures also to apply for mesh analysis. Now, we will try to obtain using the same 6 steps. So this is a circuit which has been given for you. You are supposed to determine the current flowing in the 2 ohms resistor at the right, in this one, using mesh analysis. So how to determine the current using mesh analysis, that we will see now. Okay. So let's see how we can determine the current flowing in the 2 ohms resistor using mesh analysis. Okay. So we will go by step mechanism. We know that step number 1, what is step number 1? You should identify the number of meshes in this circuit. So how many meshes are there? If you can see, this is 1 mesh, 2 mesh and 3 meshes, right? So there are 3 meshes in the circuit. Step number 2, assign a current for each of these meshes. And ensure that it is in clockwise direction. So there are 3 meshes, so I'll take I1 and I2 and I3. I'll take this as I1, this is I2 and this is I3. Understood? So all in clockwise direction. Now step number 3 is a crucial one. We need to identify the currents in all elements. Isn't it? So in this case, say how many meshes are there? 1, 2, 3. 3 meshes are there. How many elements are there? 1, 2, 3, 4, 5, 6. Right? So what I will do is nothing but I'll write a table here. So how many elements are there? I'll write elements. There is 4 ohms resistor. There are 2 4 ohms resistors, right? One is on the left, the other one is on the right. So I will write it like this. There are 2 3 ohms resistor. One is on the left, the other one is on the right. This is on the left, this is on the right. So, and there are 2 ohms resistor. 2 numbers of 2 ohms resistor. One is on the left, the other one is on the right. Isn't it? So for all these things, what I will do, I will identify the current which is flowing in there. And I will also mention the direction of current here. See, the I1 means it will be starting at this point. Right. So this is the current I1. Now this is I3. I3 is flowing in from here to here. Right. If I take this particular element, if I take this particular element, see, how many currents are flowing in this one? This is one current, I1 current. It is flowing from in this 4 ohms resistor, left resistor. It is flowing from bottom to top. Next is 4 ohm resistor. Here it is, right? What is the only current which is flowing? It is I3 is flowing. It is flowing from left to right. If I take 3 ohms resistor left, this is 3 ohms resistor left, right? See, it is having I1 current. It is part of this loop, and there is another loop also which is flowing in this direction, right? It is part of common to 2 loops. I1 is flowing in this direction, I3 is going in opposite direction. So I'll take the current as I1 minus I3, and left to right. Similarly, for 3 ohms resistor right one, see this is the one. So what is the current which is flowing in this direction? It is I2. Opposite direction I am getting I3. So I'll take it as I2 minus I3, but predominantly I'll take it as I2 is the main current, I2 minus I3, left to right. 2 ohms resistor left one. See what is the current which is flowing? Here in this I1 is flowing. Here, what is the current which is flowing in this one? In opposite direction I2. So I'll take it as I1 minus I2. I'll take it as top to bottom. On the right side, there is only one current flowing in the circuit. It is I2, and it is flowing from top to bottom. Like this, I will identify the currents in all of the elements. Okay. Once I identify the currents in all of these elements, my next job will be, see what is the current now which is flowing in this one? It is I1 minus I3. What is the current which is flowing? I3. What is the current which is flowing here? I2 minus I3. What is the current which is flowing in this one? I1 minus I2. The current here, I2. The current here, it is I1. Now understand. This is the thing which we have tried. Now, step number 4 is writing KCL, applying KCL for each of these meshes. So I will write with mesh 1. How many elements are there in mesh 1? 1, 2, 3, 4, 5 elements are there. So I do have 5, 1, 2, 3, 4, 5 elements are there. And sigma V is equal to 0. Algebraic sum of voltage drops across all elements is 0, isn't it? So in that case, I'll start from top left. See, this is resistance is 3. This is the loop, right? 3 into I1 minus I3. Plus, this is the second element, right? Current direction is downwards itself. 2 into I1 minus I2. And here, it is moving from plus to minus, right? So automatically it is also, it is a direct voltage source, I am taking as 10. Here, it is moving from minus to plus, so it is minus 20. Here, current direction is same, so I am taking it as 4I. Now you simplify this equation, you will get, you expand this one, and so this is 9I1 minus 2I2 minus 3I3 is equal to 10. This is equation number 1. Now coming to mesh number 2, what is the equation? This is mesh number 2, right? 1, 2, 3, 4 elements are there. 3 resistors and 1 voltage source, right? So 1, 2, 3 and 4. First element, 3 into I2 minus I3. Next, it is going in the same direction, so it is excuse me, 2I2. And here it is a voltage source, it is going in opposite direction, so it is minus 10. And again, see here, the current is moving from top to bottom. This is what we mentioned here earlier. But now the loop direction is in this fashion. So I'll take it as minus I1 minus I2 into 2. So if I expand this one, I will get this is 3I2 minus 3I3 plus 2I2 minus 10 minus 2I1 plus 2I2. You must be very careful in writing these equations. Okay. So it is minus 2I1 plus 7I2 minus 3I3 is equal to 10. This is equation number 2. Like this, you should write equation number 3 also. In equation number 3, how many elements? This is I1 minus I3. This is I2 minus I3. This is I3, right? So you have to have 3 elements, 1, 2, 3 in loop number 3. This is a direction. So the first one is 4I3. It is in reverse direction, the current is in. So I will take it as minus 3 into I2 minus I3. This is also in opposite direction, minus 3 into I1 minus I3. And 3 elements, that's it. So if I expand this one, So I'll get minus 3i1 minus 3i2 plus 10i3 is equal to 0. So these are the three equations now. Now you do have these three equations. See, this is step 1, step 2, and this is what I have mentioned here. Second mesh, third mesh. Now you do have three equations. This is equation number 1. And this is equation number 2. This is equation number 3. And if you solve these three equations, then you will get I1 and I2 and I3 values. Once you get them, I have already told you in step number 6, this is step number 6. This up to these three rows we have already written in step number 3, right? What additionally I am doing, I am just writing down the current value and voltage value. How to determine voltage value? Current into the resistance. This I will be getting here. So now he is asking determine the current flowing in the 2 ohms resistor, right? In 2 ohms resistor, right one, what is the current which is flowing? 2.6829, and the voltage drop across it is, this is the voltage drop. Understood? So with the mesh analysis, you can determine the mesh currents, branch currents, voltages across different elements. This is an easier technique in analyzing the circuits. Okay, so with this, I hope you have understood. You are able to determine the branch currents and the loop mesh currents, etc. And this is your practice problem. Practice it at home, and we'll solve more problems in the classroom in the next week. Thank you.